What's up, YouTube? This is Nivan Gujral, and all humans make decisions on a daily basis. From the clothes that we're gonna wear to the food that we're gonna eat, we make decisions so commonly. But have you ever thought about computers trying to make decisions for us? This might sound crazy, but it's already being done. But computers, from ads to spam filters, are trying to predict what we would buy or don't want to see. The Naive Bayes Classifier is the most common and powerful classifier that is being used to make these predictions for us. In order to learn about the Naive Bayes Classifier, we need to understand conditional probability. And in order to understand conditional probability, we need to understand probability. Probability is the likeliness of an event occurring. For example, when you flip a coin, it could either be heads or tails. Therefore, the probability of a coin landing on heads would be 50%. Similarly to a die, when you roll it, it could either be from a number from 1 to 6. Therefore, the probability that the die would be a 1 would be around 17%. Conditional probability is the likelihood of an event or outcome occurring based on the occurrence of the previous events or outcomes. Conditional probability is found by multiplying the probability of the event that has happened by the probability of the given event. Let's take an example of a school that has a total population of 100 people, which is made up of teachers and students. The teachers and students can be described as either male or female. Let's try to figure out what is the conditional probability for a male teacher. The data states that 12 of the teachers are male and there are 60 teachers in total. Therefore, the conditional probability for a male teacher would be 12 divided by 60, which is around 20%. So now we know what conditional probability is. But in order to understand the Naive Bayes classifier, we need to understand the Bayes rule. The Bayes rule is a way from going from Pxy to Pyx, where x is the evidence and y is the outcome. Pxy is when the classifier has the evidence and is trying to figure out the outcome, which can be found from the training data. Pyx is when the classifier knows the outcome and is trying to figure out the evidence, which is predicted for testing data. And the overall formula can then be transferred to be written like this. The Bayes rule is a formula to find the probability of y when x is known. But commonly in real-world problems, there are multiple x variables. The Naive Bayes classifier is an extension of the Bayes rule where x's are independent. The classifier is called naive because the classifier makes a naive assumption that all of the x's are independent from each other. On the left-hand side of the equation, it is known as the posterior probability. Posterior probability is a conditional probability that is assigned after evidence is taken under account. On the right-hand side of the equation, it has two terms in the numerator. The first term is called the likelihood of evidence, which is the conditional probability of all x's given. Since all of the x's are assumed to be independent from each other, the algorithm will multiply the likelihood of the x's, which is the probability of likelihood of evidence. The second term is called the prior, which is the overall probability of y equals to k, where k is a class of y. Now that we know how the Naive Bayes classifier works, how do we actually set it up? Let's suppose we have 1,000 animals, which are either elephants, dogs, or lions. These are the possible cases for the y variable. Let's also suppose that we can describe these animals if they are big, have fur, or have a tail. The object of the classifier is to predict whether the animal is an elephant, dog, or lion based on if the animal is big, have fur, or has a tail. The first step for the Naive Bayes classifier is to find the priors of each animal class out of all the animals from the population. In this case, there is 1,000 animals in the population. 500 of them are elephants, 300 of them are dogs, and 200 of them are lions. The classifier will divide the number of animals in one type by the total animals in the population. Therefore, the priors of the elephants, dogs, and lions will be 50, 30, and 20% respectively. The second step is to find the proportion of each feature out of all of the animals from the population. In this case, there is 1,000 animals in the population, 800 of them are big, 500 of them have fur, and all of them have tails. Similarly to the first stage, the classifier will divide the number of animals for a feature by the total number of features. Therefore, the proportions for big, have fur, and has tail are 60%, 50%, and 100% respectively. The third stage is to find the product of conditional probabilities for the features. In the formula, it states that Px1, y equals k, x1 is the feature, and k is the animal class. This means in order to find the probability, the classifier will divide the number of animals that a feature is present in by the number of animals in that population. For example, the data says that there are 450 big elephants. Therefore, big elephant will equal to 0.9 because 450 divided by 500 is equal to 0.9. After finding the probability for each feature, the classifier will then find the product of all the probabilities. The algorithm will then continue this process until it has found the product of all of the probabilities for each one of the animal classes. The fourth and final stage is to substitute the product of the probabilities into the Naive Bayes Classifier to find which class will have the highest probability. In this case, the elephant will have the highest probability out of all of the animal classes. But wait, there's a problem. The probability of an elephant will be 0% since at least one of the features is not present in any of the animals. This makes sense, but when the Naive Bayes classifier has many features, the entire probability will become 0 since one of the features' value was 0. In order to avoid this, the classifier would increase the count of the variable with 0 to 1 in the numerator, so the probability would never become 0. This method is called lopside correction. So in our example, the elephant would actually have a 90% chance probability. The Naive Bayes classifier provides intelligence to applications that most of us use every day, and is transforming the way that computers can make real-time predictions. Currently, it is being used primarily to make real-time predictions. It can be used in recommendation systems and predict if a user would like a certain resource or product. It is now having a widespread use in in-text classification as it has a higher success rate compared to other algorithms. Even though the Naive Bayes classifier can have many different applications, it has some limitations. One limitation is that it assumes that all of the attributes are independent. Another limitation is that it treats all of the attributes equally, so some weights can't be added to be more important attributes to increase the contribution in their final decision. The Naive Bayes classifier is still the most common and most powerful classifier to date, and it is a foundational tool that is improving artificial intelligence potential. Thanks for watching the video, and if you enjoyed this video, please make sure to like the video, and if you're new, please consider subscribing to the channel as well. If you want to see me make another science or technology video, please comment it down below. If you want to learn more about the Naive Bayes classifier and how it works, you can check the description for an article that I wrote on it. Thanks for watching, and see you guys next time.